Okay, so now we are ready to create our mathematical model. So this is not an easy thing, and almost always we start by defining sets, indexes, and variables. Okay, so we know there are some entities in our problem. There are customers, there are candidate locations, and there are scale levels. Okay, these are some things that we need to worry about in our problem. So let's say I, J, and K, they are the set of customers, locations, and the scale levels. Later we will see how they may be used. And very quickly we would say the small I, small j, and the small k, each of them are indexes. They represent a customer, a facility location, or a facility scale level. So throughout our model, whenever you see small I, you know that's a customer. Small j, that's a facility or a location. And a small k, that means a scale level. Then we are ready to define our decision variables. As we always mention, you always define your decision variables before you define anything else, before you define parameters, before you define objectives. Okay? Because whenever you are trying to tell anybody what's in your model, you always let them know what's the decision that your model is going to make for those decision makers. So our model is going to make a suggestion on whether to build a facility in which scale level. So xjk would be 1 if a facility is built at location j with scale level k, or 0 otherwise. So in this case, xjk certainly has j and k with location and scale level as the indexes, because for each location j, you choose 1 out of all those possible scale levels. Okay, so xjk is our main decision variables. And then we also need to do customer assignments, right? So yij is 1 if customer I is served by site j, which means facility j. Okay. And finally, wj is the number of engineers that are allocated in location j. So once we have this set of decision variables, we have covered all those decisions that we need to do. We need to deal with models, and we need to use the model to determine facility construction, to determine customer assignment, and engineer allocation. Now we are ready to describe more information that we need for building our models. Let's say fjk, I'm sorry. So fjk is the annual office rent for building a facility at location j with scale level k. So you may expect at different location, the typical office rent is different. And if you need a larger space, then you need to pay more. So that's why here your f has 2 indexes. The office rent is different from location to location, from scale level to scale levels. You have hi, which is the annual number of services that are needed for customer I. So for different kinds of customers, this number may be different. For post offices, maybe you need to go there very frequently. But maybe for 7-Eleven, you don't need to go there very frequently. And for a Taipei post office, maybe it's very busy, so you need to go there for a lot of times. But maybe for one in Taidong, you don't need to visit there many times. So that number may be different from customer to customer. Between a facility and a customer, there is a distance. And that distance also has something to do with the route that you need to go through. So there must be a different cost between locations. That cost is per service cost for you to send one engineer to travel between facility and the customers. Okay, so dij is that cost for sending one engineer to do the service between facility J and the customer I. You have a cost Cj. Cj is the cost for hosting one engineer in location J. Again, that cost may be different from locations to locations. Mjk. Mjk is the maximum number of engineers that may be hosted in facility J with scale level k. So scale level k is, for example, there may be several different scale levels. Let's say scale level 0 means you don't build a facility layer. Scale level 1, 2, 3, 4 is become bigger and bigger, but for Taipei, scale level 1 may be having a different space that is different from the scale level 1 in Taichung. Or maybe in Taichung you only have 2 possible scale levels. Maybe in Taichung you have 3, maybe in Taipei you have 4, and so on and so on. And maybe scale level 1 in Taipei means 100 and so 100 ping or something like that. And maybe in Taichung that means 80 ping and so on. So somehow in any particular location J, as long as you choose one scale level, then you know what's the maximum number of engineers that may be hosted there. Okay, so that are some concrete numbers that you need to know so that later you may determine whether your engineer allocation is feasible. Whenever you want to allocate engineers, there's a reason. It's because that an engineer must provide some services. But each engineer only have 8 hours per day, and each engineer need to take some holidays in a year. So there is a maximum number of services that an engineer may complete in a year. Let's call it small s. And let's assume that number is pretty much the same throughout Taiwan. So if that's the case, then that's a number that all these kinds of companies is going to estimate, because that directly tells the company how many people we need to hire for this particular technical service. Okay, so S is roughly, let's say 1,000 or 1,500 and so on. That's the number of services that an engineer may complete roughly in a year. And then finally, there is a parameter called Aij. Aij is what? Okay, so this is a small Aij. Aij is a binary parameter. Don't forget, it's a binary parameter instead of a variable. That parameter is saying that if Aij is 1, that means location J and customer I, they are close enough. So what does that mean? Suppose you have a post office here, and suppose you have a facility there. Maybe the distance is just too far from each other, so that you don't have enough time to go there by sending an engineer from facility J. Because almost always when you sign a contract with, for example, 7-Eleven, or when you sign a contract with a post office, they will say that, okay, after I call you in 2 hours, you need to send someone into my stores, something like that. So you have that 2 hours, 4 hours constraints. And if you really have a 2-hour constraint, there's no way that a Taipei facility may serve a post office in Kaohsiung, right? In that case, we would set that pair of Aij to be 0 if facility J is not close enough to the customer I. If that's the case, we set Aij to be 0 so that even if your facility J is open, it cannot be used to serve customer I. So that's all the parameters we need.